All right, hi. So today we begin our discussion of lecture series number 3, which is software project management and organization. And just a quick reminder that for those of you that didn't attend the live hangout session that we had, we did mention that we've swapped the order of the topics around because of this sudden shift in the mode of instruction. So we're ideally supposed to have covered requirements engineering, but we decided to cover software project management so that we can already get started with coming up with the different artifacts associated with the group projects that we're working on, right? So take note. But before we start, just a few announcements. Number one, you want to check the calendar. If you haven't bookmarked the course calendar, make sure you bookmark it. The important activities that have been scheduled there. Two important things though that I thought I'd mention. There's going to be a batch of team tasks and assignments that are going to be shared on Friday. So be on the lookout. There are due dates associated with these tasks. And then we have a scheduled live query and answer session, which is Thursday next week, May 7th. And the idea is to give you the opportunity to ask questions that might be aligned with what we've covered so far and what we're going to cover in this particular lecture series, at least at that point in time. And then, more importantly, what we've noticed, so we track what's going on the Moodle, right? And what we notice is that the vast majority of you are not gaining access or are not accessing the complementary material that is being shared on the Moodle, right? So those things we're tagging as reading lists. Very important things. You want to make sure that you read those things. The slides are no substitute for the recommended text associated with the course, right? And more importantly, you want to make sure that you read through those different peer-reviewed articles that we are sharing as well. All right, so the lecture series number 3 is segmented into 5 main units, and we're going to go through them in sequence, really, beginning with just introduction to software project management. And I'll just switch this thing off here. All right, so it turns out that really software engineering is no different from the more traditional or mainstream engineering disciplines like civil engineering, electrical engineering, right? And in fact, most of the aspects associated with software engineering, being a relatively new field in its own right, are borrowed from these more traditional domains, right? And I just want to draw attention to certain key things that might be linked to software engineering insofar as these other traditional domains are concerned, right? You immediately notice that there are key traits associated with potential costs of the project and timelines, completion dates and start dates of the projects that are common within the different engineering projects. So typically money is invested to embark upon these different engineering projects, and so quite naturally there are individuals that are generally tasked to make sure that these projects don't go over budget and that they are completed within the stipulated period of time or time frame, right? So this screenshot or this slide just shows 2 projects in Zambia. So the one on the left is a civil engineering project. I'm not sure if they've completed this, but the last time I used the Great East Road, I think most of it had actually been rehabilitated. That was sometime last year, I think. And then you probably want to look up the ZESC optic fiber network project. So there's this grand plan to interconnect all the various towns, the various regions of the Republic of Zambia, right, using fiber cables. If you look at this legend here, it showcases parts of the country that have already been connected, planned projects with associated years. You notice that the yellow and the blue seems to suggest that these have been completed actually. Excuse me, coffee. All right, so back to this idea of course, right? Again, just to emphasize by using the example of the so-called Lusaka decongestion project. If you look up the project online, I mean, this is a civil engineering project, but if you look up the project online, you realize that there's interesting numbers being thrown around, right? But important numbers that I want to draw attention to are issues to do with the cost, right? This is a large-scale project that has attracted investment from the Republic of Zambia, also the government of the Republic of Zambia, and the government of the Republic of India, right? I don't know if that's what they refer to themselves, but I guess this is the point. Right, so cost, like I said before, and time frame, right? So from inception, this Lusaka decongestion project is expected to take 3 years to complete, right? And of course, tied to the cost and the time is this whole notion of quality. The last thing you'd want is to actually have parts of the roads that are being rehabilitated as part of this project being shoddy, right? Or wearing out a few months or a few years after project completion. So there's a quality aspect associated with this, right? So again, just to kind of emphasize the fact that this issue of quality and cost, including time, transcends into software engineering as well, or development and implementation of software. I thought I would showcase some examples. So a while back, a couple of years ago, probably a decade or so, the Zambian government embarked upon the so-called IFMIS project, essentially the implementation of an integrated financial management and information system. I'm not really sure how far they've gone with this project, if they actually completed it successfully and within budget and on time. But you notice from the cost here that a lot of money was put into this project, right? And remember that this was just the share coming in from the government of the Republic of Zambia. So money, cost, right? Very important aspect of projects. And then, I mean, once we start talking about this issue of quality, you slowly realize that there are certain software projects or certain software systems that are classed as being mission critical, right? So doing anything silly or stupid would potentially result in the loss of lives, right? And I'll draw attention to more recent disasters associated with the Boeing 737 MAX, right? People died. Why? Because of a software glitch, right? So quality, right? So all these different things that I just mentioned here, issue of quality and making sure that the product is delivered on time and within budget, are really important motivating factors that have led to the mainstreaming of project management insofar as software engineering is concerned, right? And it turns out that this whole issue of project management actually began in the 1960s when something very peculiar happened. The so-called software crisis manifested itself. And so what people realized was that somewhere in the 1960s was that the cost of hardware, right? The relative cost of hardware was going down. But then the surprising thing is that the opposite was happening insofar as software engineering was concerned, right? And in fact, during that particular period and a few years after that, a number of high-profile large software projects ended up failing, actually. They were overdue. They went over budget as well. And were, for the most part, of low quality, right? It turns out that one of the reasons why this was the case, or at least one of the reasons cited, is that at the time, techniques that were being used to develop and implement software, were really borrowed from the small-scale software project that had been embarked upon prior, right? And unfortunately, those techniques could not really be applied to these large-scale software projects, right? It gets even better. So interesting statistics have been collected by certain entities. Most common or most popular statistics are the ones that are produced by the Standish Group. So beginning could be the 90s or maybe the early 2000s, they began to really collect statistics associated with success and failure of software projects, right? So this graph just shows you the most recent report. I'm not sure if this is the most recent report or if it's the very first Standish report that was produced, even though the pattern has changed slightly, but really the segmentation of these three different strands is more or less the same. But key takeaway point here is that you immediately realize that for the most part, most software projects, right? Most software projects end up being challenged to a certain extent, and the challenge is usually associated with going over budget and being overdue initially, right? You know that less than 50% are actually considered successful, and then a considerable chunk actually end up as failed projects, right? So all this is motivation, or all these are motivating factors for why software project management is extremely important, right? What the Standish group have done is they actually have narrowed down to try and see if the patterns change when you look at the data based on the different domains. And it turns out that even though there are intrinsic differences between the different domains, but by and large, you notice that still the proportion of projects that end up being successful is generally less than 50%. Right? And clearly here, this data was collected between 2011 and 2015 here. Of course, granted, these statistics are just being pulled from sample software projects, but they give you an idea of what's actually on the ground. Right? So the question then is, if software can potentially end up failing, what exactly determines whether or not a particular software project is successful? Well, it turns out that smart people have come up with aspects associated with software. Initially, the so-called triple effect was one of those most widely used way of assessing the relative success of the project, essentially looking at three key aspects, so the quality, cost, and time. But increasingly, and this is not coming from the Standish group, I should change this. Increasingly, so entities such as PMBOK have come up with additional aspects associated with risk, for instance, and resources associated with the project. So what you're seeing here is what's called the star pattern, where all these different aspects are taken into account to assess whether or not a particular software project is considered successful. Right. So obviously, hopefully all these different motivating factors have helped contextualize why it's important to incorporate software project management, or at least project management techniques when developing software, right? It turns out it's an extremely important aspect of software engineering. Even more important when compared with the more traditional engineering projects, right? Why? Well, the reason is simple, right? If you look at software and if you were to compare it with these traditional engineering disciplines, you immediately realize that it has certain characteristics that are not shared with these other disciplines, right? So it's of course intangible, right? It's not something that you can touch, right? And because it's intangible, it becomes difficult for you to measure progress, right? Think about this for a second. If if we were to look at how the so-called Lusaka decongestion project is being assessed, one would argue that one of the success criteria or metrics being used to assess progress is to see how much of the roads that are being worked on have actually been completed, right? And you realize that it becomes very easy to measure if you take into account those sort of metrics, right? Software, on the other hand, when developing software, one of the obvious things that you'd potentially use to assess progress is things like the number of lines of code or the features that have been implemented. And it turns out that it's difficult, right? It is possible in certain instances, but it's difficult to measure or assess progress because software is intangible. Right? And then also, if you look at most of these large-scale software projects, most of them are usually bespoke or custom software projects. And the problem with that is that it becomes difficult to learn from past mistakes. If I'm a civil engineering firm and I'm contracted to build a road and I've built roads before, I can easily borrow from what has been done before. It becomes difficult when you look at software engineering, especially if you're in the business of implementing bespoke software. The other reason is it's usually the case that the technology stacks that could potentially be integrated or used with the software could suddenly change, right? And we've seen this happen over and over again. This could be upgrades to the hardware, for instance, or software components that are required or a requirement when it comes to the software that you're implementing, right? So all these factors make the field of software engineering even more harder to manage when compared with the more traditional engineering disciplines. Right? It turns out that there's certain important factors that influence this thing we are calling project management, and we'll of course define what project management is. But a few things worth mentioning here is the relative size of the company, obviously, right? So factors like the software customers that have approached you to develop software on their behalf. The size of the software, whether it's a small scale project, it's going to be a relatively small software, medium sized, or maybe large scale, right? And the type of software, what sort of domain are you working with? Are you developing software for the financial sector, in which case you know that money is involved? Are you implementing a piece of software that's going to be used in the health sector, right? Perhaps an AI-centric application that is meant to help doctors make important decisions, right? So you realize that these are all important factors that need to be taken into account. So other more, I guess, esoteric factors include organization culture, the sort of software development process that you'd end up adopting as a software development firm. And really, key takeaway point here is that with all these factors mentioned, it becomes crucial that the people that are running these software projects work in different ways depending on the size of the company and software type that they're implementing. Right? So, for instance, I mean, if I was developing a mission critical piece of software that's supposed to help navigate some expensive spacecraft into space, right? The last thing I would want to do is to use incremental development process. Why? Because careful planning is required. And so maybe the appropriate software development process that would have to be used would be the traditional waterfall model, for instance. Right. All right. So seeing as, I mean, we've set a stage for why software project management is important, the question then, before we define what software project management is all about or is, the question to ask though is, what exactly is a project, and what sort of important elements is it composed of? If you're looking for a textbook definition, I don't know if I'm the one who came up with this or if I just came across it in textbook or something, but it's essentially a goal-oriented, time-constrained activity that is associated with a predefined budget, right? You will immediately notice that this particular definition involves three key things. You're generally working towards a broader objective or goal, right? This would be developing a piece of software that takes into account all the list of requirements dictated by the potential users of the piece of software, your customers, right? So goals and objectives. Time constraint, because usually you have limited time frame within which this project is expected to be undertaken. And of course, it's associated with the budget because there's a predefined amount of money that is associated with the project. The goal is always to make sure that you do not go over budget, that you implement this project within the prescribed duration, and more importantly, to ensure that all the project goals and objectives are met, right? So again, definition, goal-oriented, right? The project is nothing more than goal-oriented, time-constrained activity associated with the budget, right? And you notice, I mean, you can apply this definition to most things in life, actually. You could view you undertaking or enrolling into this course we're calling ICT 3020 as being a project. The end goal is you want to pass. Perhaps one of the goals is you want to get a really good grade, right? It is time constrained, obviously, because we know that at a certain point in time, we'll be writing these assessments, we shall write the exam. Is it associated with a budget? Well, of course, right? You're not attending lectures for free. You've paid money in the form of tuition fees. Your parents and guardians are paying money for your upkeep whilst you're on campus, right? Of course, you're home now. But of course, you're spending money on bundles to access teaching and learning materials, right? So budget, time, and goals, right? And in terms of the key elements associated with the project, again, tied to the definition and the things that we've already discussed, you immediately appreciate that if you're talking about time, then it makes sense that the project should be associated with when it needs to be initiated. So the start date, how long it's going to take, right? And of course, if you know how long it's going to take and you have a start date, you can easily derive the end date. In certain instances, you could replace the total duration with the end date, in which case you derive the total duration of the project. And then obviously tied with this issue of time is a schedule. Because you're working with a limited time frame, you obviously need to plan for this. You come up with a schedule on when you're going to perform specific tasks associated with the project. More on that soon. We'll discuss those things in coming slides. And of course, a project is generally associated with milestones and deliverables. So milestones, this will be like key phases of the projects that will mark or signal progress being made as you're embarking on the project. Deliverables will be actual tangible projects that are being generated as you are undertaking the project. And of course, technical and management tasks and activities, the different things that you do as you're working towards the projects. And then finally, a project is composed of resources, right? Key resource here being human beings, right? Of course, there's a broad range of resources. Money could be viewed as a resource here. Different tools that you'd use to accomplish key tasks of the projects would be considered resources. Right, so obviously you have this goal that you're working towards. The logical thing to do then as you're embarking on the project here is you soon realize that it needs to be segmented into smaller manageable tasks and activities, right? So a project is generally composed or segmented into activities and tasks, right? And again, textbook definitions here, an activity is nothing more than a unit of work that will, for the most part, result in a key milestone or deliverable associated with the project, right? And the slide here has a screenshot showing some sample activities here for a project that we were working towards end of last year. A funny story though, this project was a failure actually, mostly because of the people we were working with. And incidentally, some of the people that we were working with are in this class, right? So an activity is a unit of work that will result in a milestone. So if you view these things that are falling under this to-do section and the in-progress section, all these are activities. What we're saying is that each of these distinct activities are expected to result in either key milestones and or deliverables, right? And of course, an activity is generally associated with some sort of schedule. So for instance, this development environment activity will be associated with its own separate schedule. So the time when this particular activity will need to be initiated and when it ends, right? And by the way, the dates you're seeing here on the activities were the due dates, the end dates for these particular different activities, right? Okay, and then a task or tasks are actually derived from activities. These could be viewed as being the smallest unit of work, right? That can be tracked. So anything that is a part of an activity, right? Broken up from an activity that can be tracked and is considered a unit of work is what we're calling a task, right? And the idea of breaking up activities into tasks is to make it a lot easier for you to work towards accomplishing that particular activity, right? All right, so key things that are associated with tasks here is when it comes to project management is usually you have certain entities, or it could be human beings or specific roles that are associated with tasks. So if there are people that are a part of the project, then the obvious assigned roles and they're expected to work on the smallest unit of work. Again, similar to an activity, because you're tracking this task, it's associated with time, dates, start date, end date, or start date, duration. Right? And then, more importantly, because tasks are derived from activities, and it goes without saying that they're linked to activities, right? So you have a project, you first of all break it up into activities, then those activities are further broken down into tasks. Tasks associated or assigned to roles. So this whole notion of tasks and roles and human beings is really tied to this notion of teams, right? So, or human beings that are working as part of that project. So typically, we mentioned that a key resource associated with a project is obviously human beings, right? And usually it's usually the case that those human beings would form so-called project teams that are a part of the project, right? And the idea behind this is that once you form these teams, the individual team members who are human beings will be assigned specific roles associated with the project. These roles would ideally be mapped onto different functions that need to be performed for the project to be successful, right? Those roles would be assigned responsibilities, so things that they would be expected to do, right? Then obviously the roles would be the team members would be assigned the roles, and then team members would be assigned tasks that are linked to the roles, right? So this block diagram here just shows what I was talking about just now. You have a project, it's linked to activities. Each activity is broken down into tasks, right? So these project tasks would be linked to the different activities associated with the project. The tasks would be assigned to different roles associated with the project. Each team member will be assigned a role and subsequently assign tasks based on the roles they're performing. So observe example of these group projects that you're working on. At some stage, once you start the development, perhaps you might decide to assign specific roles to different group team members, right? Developer roles, designer roles, tester roles, right? The people that are going to go through the quality assurance process, validation and testing, right? And then you come up with a list of all the different project tasks associated with the different activities of this project you're undertaking. Those tasks will be loosely tied to the different roles. So there'll be tasks related to programming, tasks related to designing of the software, tasks related to requirements analysis or engineering, right? And then you might decide as a group to say, amongst the four of you, you will have individuals that will be assigned the role of requirements engineers and developers, the task of designers and testers. After you do that, then you'll be able to distribute these tasks based on the roles that the different members are exhibiting. Now, at some stage, once we start looking at teamwork and group composition, we loosely gloss over this idea of potentially doing this informally in such a way that all the different team members in your group are assigned the same roles. So if there's 4 of you, all 4 of you will take up the developer role. All 4 of you will take up the designer role, right? And then you distribute the tasks, right? So the obvious disadvantages and advantages to all of this. It works quite well for an informal project like what we're undertaking right now. But when you're working on a large-scale project, right? Case in point, something akin to the so-called IFMIS project, last thing you want to do is to have all the different project team members be assigned the same roles. No, right? All right, hopefully that makes sense. Elements of the project. All right, so the obvious question then is what sort of activities are associated with this thing we are calling project management, right? Or software project management. What does this involve? Well, it turns out that there are certain key aspects associated with software project management. And these are the things that we are going to spend a lot of time discussing in this particular lecture series, actually. The remainder of the lecture series is segmented in this particular manner. So you obviously have to undergo a thorough process of project planning, right? So whoever is overseeing this project, typically these would be entities referred to as project managers. They'll be the ones responsible for the end-to-end planning of the project. So these would be things to do with estimating the cost and the resources that would be required by the project. And there are systematic ways of doing this, by the way. They'll be the ones responsible for coming up with the schedule associated with the project. So start, dates, and durations for the various key activities, and in certain instances, tasks associated with the project. It's also their role to identify individuals that will be assigned specific tasks associated with the project. So all of this is tied to planning, right? And you soon realize we soon realize all of this, or appreciate all of this, once we go into depth for things like scheduling, for instance. Again, tying this to the 30-20 course that we're working towards, all of you would probably be involved in the end-to-end process of planning, estimating, and scheduling of the project, right? Just because for us this is a learning process. Right? But if you find yourself in a situation where you're working on a relatively large-scale project, then you'd potentially leave this to project managers. And believe it or not, there are people that spend months, years sometimes, studying project management. Right? There are people that are explicitly hired as project managers for entities like NGOs, for instance, right? If you go to Zambia jobs, for instance, you'll be amazed as to how many jobs you find that are loosely tied to project management or project management manager roles. And of course, one of the things you need to do as part of software project management is you need to manage the people. Remember, if you're working on a large-scale project, you'd have potentially hundreds and sometimes thousands of people working together in unison to work towards the overall goal, right, of the object of the project. And because you are working with a lot of people, you need to manage those people somehow, making sure that they're actually working, making sure that they're doing the right thing, right? And of course, as with most things in life, there are risks associated with undertaking a project. So you want to make sure that you go through a thorough risk management process of identifying risks and analyzing risks and mitigating risks, right? Prioritizing risks, and we discuss all these things shortly. More importantly, though, as part of the software project management activities, you obviously need to come up with important documentation, reports tied to progress being made on the projects. Reports tied to things like how much money is being spent, right? And incidentally, one of the very first reports that we are going to write as part of the assessment in ICT 3020 is this so-called proposal. It is a report, right? And it turns out to be one of the very first stages in software project management. right? It's usually in the real world, you write a proposal as part of a bidding process. So if you come across a project that somebody has created a tender for, maybe in mainstream media like the Daily Mail newspaper, for instance, one of the things you're expected to do is you write a proposal outlining exactly how you would undertake the project, how much money you would spend, right? So that's considered a report. And what it does is it essentially describes the overall objectives of the reports of the project, and more importantly, how you are going to conduct that particular project, right? To recap, these are the key things that you work towards as part of software project management: planning, people management, risk management, and reporting, right? Okay, so to recap here, we started off by providing a motivation for why software project management or project management is important when it comes to software development or software engineering. We really started off by looking at it's actually two examples really, the infamous project and then the Boeing Max 737 debacle, right? And then we touched on the so-called software crisis of the 1960s, which was actually one of those reasons why software project management became important or an integral part of software development. And then we looked at the key elements associated with software project management, right? Key parts or entities or elements associated with software project management. And then we ended off by looking at really those important aspects associated with project management. So we highlighted things like planning, scheduling, risk management, and reporting, right? All right, so in the next unit, we are going to go through a thorough process of discussing project planning. Thanks, and I'll see you in the next unit.